Welcome to another episode of Chemistry from Jay's House. Today we're going to be talking about, reviewing acids and bases. So, this all comes from, if you have two substances and you don't know what they are, how can you decide whether they're an acid, a base, or nothing? And the answer is, what we used to do, and this is a really long time ago, this is the time of like Greeks, is we would either taste them, and if they tasted sour, or if it dissolved metal or corroded metal, then it got the fun name acid. Or if it instead of tasted sour, so sour is like lemon, right? The citric acid in lemon makes it sour. If it tasted, instead of sour, it tasted bitter, and think of what soap tastes like, or if it's slippery, such as, put dish soap on your hands and try to get it off, it's really slippery, right? Then if that was the case, then it would got the fun name base. And that was fine way back in the day of the Greeks when we didn't even have scientists. This was actually discovered by philosophers. That's people who thought deeply about the world were called philosophers, and we didn't even have science yet. And that worked fine for a while, but then we started saying, you know what, we should have a scientific way of deciding if something is an acid or base, and it shouldn't involve putting it in our mouths. That's a terrible idea. So scientists said, okay, how can we formalize whether something is an acid or a base? And the obvious first choice is, well, there's this substance that we use all over the place, and it's called water. What if we, throw the chemicals just in water and just surround them with water and just see what happens? Because, water, that's how we define Celsius, that's, required for life. Stuff dissolves in it. It's kind of a nice starter substance. And so we threw these things in water, and we noticed, with this substance over here, what happened is a whole nother proton attached to the water. So what we noticed is, hey, over here, we don't just have water, we also have this stuff called hydronium. That's weird. And we noticed that, hey, water started becoming hydronium ions, which is H3O+. So around this substance over here, water was changing chemically from water to hydronium ions. We said, oh, okay, chemically now we have a way. Throw it in water, and if H2O becomes H3O+, now you get the fun name acid. And over here with bases, we said, oh, that's weird. Water isn't becoming hydronium, it's actually becoming hydroxide. So we noticed that around the bases, we were getting hydroxide ions, which are OH negative. So if we pour this stuff in water, H2O becomes OH negative. And if that's the case, then we'll get it the base. So now we had a very technical way of deciding if something was an acid or a base. What happened to H2O? Did it become a hydronium ion, or did it become a hydroxide ion? And then scientists were like, ooh, we should probably, let's really drill down on this. Let's really figure out the mechanics behind that. Why is water becoming hydronium? Why is water becoming hydroxide? So they went even deeper, as scientists often do, and they started asking questions. So let's start with this substance over here. What happens to this substance? When we throw it in water, what we notice is that this substance seems to have these extra protons. And how did we know that? Well, let's figure that out, because we didn't really know that to begin with. We started off with saying, hey, I know that we start off with water. We start off with H2O. And if we throw this substance in, I know that we end with hydroxide hydronium ions, H3O plus. But the question is, so what happens? What do we add or take away from water to get there? And scientists, well, they just figured it out. They said, well, I know it's not an oxygen because I have one oxygen here and I have one oxygen there. So this definitely does not have any oxygen in it. Okay, so you don't need oxygen to be an acid. Gotcha. And so, but we have 2 hydrogens here and we have 3 hydrogens there. So I'm no scientist, but my guess is you're adding a hydrogen. Okay, that sounds good. And this doesn't have a charge, and that has a positive charge. So my guess is that you're adding a positively charged hydrogen ion. Okay, so let's just check the math really quickly. 2 H's plus 1 H gives you H3. That looks good. 1 oxygen plus nothing. No oxygens gives you the 1 oxygen. And no charge plus a positive charge gives you a positive charge. Okay, that looks good. And I said, you know what? We are going to call that an acidic hydrogen. If you have an acidic hydrogen, if you add a positively charged hydrogen ion to water, then you are an acid. So if you can add one of these, an acidic hydrogen, to water, you are an acid. And that's how we chemically figured out what an acid is. But you'll see in part 2, we're going to drill down on this a little bit more. And we're going to talk about what is a positively charged hydrogen ion, what is an acidic hydrogen, looking at a hydrogen. So that'll be part 2. Unfortunately, my phone lost the first part of the video, so I'm re-recording it. So tune into part 2 where we talk about what is a positively charged hydrogen ion based off of a single ion. What does this look like? There it is. On to part 2 with you.